talk about the dot product. So the dot product, we actually have two definitions for it. The first one is a little more algebraic, so let's go ahead and do that one first. So it says the dot product of A and B is just the first component of A times the first component of B plus the second component of A times the second component of B, and so on and so forth. Not that interesting. The second one is a little more interesting. It says, look, the dot product of A and B is the magnitude of A times the magnitude of B times the cosine of the angle between them. Let's go ahead and see on a little figure what that means. Well, this is A, all right? Then it wants us to multiply that by B cosine theta. Well, this is the magnitude of B, and this is theta, so B cosine theta is just this length, right? So in fact, the dot product is of A and B is this length times this length. So really, the dot product, what it does is it takes one vector and multiplies it, or it takes its magnitude and it multiplies it by the component of the other vector that's in the same direction. Took one vector, multiplied it by the component of B that's in the same direction, right? Well, that's sort of useful. That's kind of cool. Why? Why do we care? Because it allows us to sort of say, well, I don't care how far you're going. If you're going 30 yards out that way, and I'm going, 5 yards out this way, what I'm interested in is, well, how far have you come in my direction, in the direction that I've walked in? A lot of the times that question comes up, as you'll see in just a few chapters. So then it gives rise to all this component and projection business, and they may seem a little convoluted and complicated at first, but they're in fact very simple. So the component of B along A, it's got a couple different notations, but this is the basics of it. Component of B along A is just how far is B going in the direction of A. Well, it's just what we calculated. It's B cosine theta, right? But that's not the way you're usually going to see it. You're usually going to see it written this way: A dot B over the magnitude of A. Okay? So this is convenient because you don't need to know the angle between the two vectors, because a lot of times you don't. You'll just be given, oh, well, you have this vector and that vector. What's the component of B along A? And you'll be able to get it. And again, I got it by, this is just by looking at the figure and looking at what the component of B along A means. It's just B cosine theta. And then I use this formula. A dot B is the magnitude of A times the magnitude of B times cosine theta to get this guy. Okay? So what about the projection of B onto A? What does it mean? Well, it's basically the component of B along A, except in vector form. So it's saying, look, I want to know how far am I going in the A direction, and I also want to know my direction. Okay? So all you do is say, okay, well, you're going this far, you're going, this is my component, the component along A, and now we got to give it the direction. Well, the direction is just going to be the same direction of A, right? Except A itself has some magnitude. So first we want to divide by A's magnitude so that it's a so-called unit vector, right? It's a vector that only has a direction. Its magnitude is just 1. So it doesn't mess up our magnitude business. So because the significance of this is that it's the magnitude of the component of B along A. And so if this itself had a magnitude, it would mess up the meaning of this guy. Okay, so we multiply by the unit vector, and it gives us both the magnitude and the direction of the projection of B along A, which is going to be this vector right there. Okay, so there you have it. That's a dot product and a couple applications of it.